Hello everyone. For this IR 535 project, we have developed a multilingual search system. Our team name is 5bits and this is our demo. Now, I'll first go through the tech stack. For the tech stack, we have used Solar in our backend, which is used to index all the tweets we have. We have an entire corpus of 18 lakh tweets. As a middle layer, we have used a Python Flask microservice. The main functionality of Python is to expand based on the query and also do all the analytics, extract important data from the retrieved tweets from the Solar. We have also used a MongoDB database to store all the query logs as well as relevance logs which will be explained later on. And in the front end, we have used JavaScript and Bootstrap along with HTML. We have kept the UI simple as possible. Now this is our UI. Now I'll go through the demo very quickly. Suppose if you query the query term social, you'll see we are returning only the top 1000 results as that much is only required. Now you can go through multiple pages. We have implemented the pagination feature also using Ajax call so that the front end only gets returned 10 tweets at a time. Now over here we have filters based on topics, cities and languages. Now you can apply multiple filters at once and you can see the change in results accordingly. Similarly, it goes for cities and languages. Now the filters don't work as normal filters. They are not filtering the retrieved tweets, but rather they are making a facilitated query to the Solar, as I'll show you right now. Consider the tweet filter environment. As you see the number of results, okay, we'll consider crime for now. You'll see the number of results don't decrease. This is because it is making a new request to Solar and adding the filter based on crime. So the number of returned results is still greater than 1000, so we are getting 1000 results. If I add environment and delete to our filters, we can see that the number of tweets returned are quite low. And if the user wants to expand based on the first query, we have also implemented a pseudo relevance feature which he can use and expand on the original query. This can be used to increase the recall value by a very large amount. Now you can also click on some particular tweet and go to that particular tweet's Twitter webpage. You can also follow the person, you can see the original tweet and navigate even more. Similarly, it can be done for all the tweets. Over here we have mentioned the entire tweet text and hashtags are highlighted so that the user it catches the user's eye. Now all this data which we entered over here or we clicked over here has been stored in the database, which can be seen over here. We have hosted the database on the Atlas MongoDB server. You can see we have two collections. One is all logs and one is relevance. All logs contain essentially everything which you search for. For example, which over here I'll explain how it works. We have a timestamp at which the query was made, what filters were associated with the particular query, and what the response was. Consider this one for an example. The query was social. The filters were for this query we have no filters. No, we have a single filter, that is we want the tweets only in Spanish language. And over here you can see the tweet IDs of all the returned documents. Now this can be used to later optimize our search engine and see how our search engine performed earlier. Similarly, we have relevance logs, as you can see over here. In the relevance log, when a user clicks on a particular Twitter ID, its tweet ID will consider that the particular tweet is relevant to the user for that particular query. So we are also storing that in our database. These are all the query logs, as you can see. For example, the original query, the location filters associated with it, the topic filters, language filters, and the tweet which the user marked as relevant. And also the important thing is we are also marking the timestamp in our database. Now I'll move back to the demo again. Now this was the search part of the search engine. Now we'll move on to the analytics part. Now since the city filter is Delhi, you can see all the tweets are from Delhi, all 146 of them. Now I'll remove the filters to explain how the analytics is working. The entire analytics part is dynamic. It is not static. It is based on per query. As you'll see now, the analytics has been performed based on counts, based on time series, sentiments, hashtags and mentions. Now we'll go through each one of them one by one. Now this is the distribution based on location, based on languages and based on topics. For all these three, we have used pie charts as it is more intuitive for a count to be visualized as a pie chart. as you'll see what percentage of the data is a particular topic or a particular language. Now, we have done also the time series analysis. The time series isn't on weekly basis but on a daily basis. For example, if I go to a particular point, you'll see on 9th October, I have one tweet from Bangkok, one from Mexico, four from Delhi, one from Paris, and 22 from New York City. Now, I know this graph doesn't look very good to understand. So what you can do is you can remove few of them and understand each of them individually. And even when you're understanding each of them individually, you will see the results of other three so that you can make a comparison. Now this has been spanned from September to November, and the tweets are varying from 0 to 25 based on the city and date on a particular day. Now similar analysis has also been done for languages and for particular topics. So you can analyze what the variation for a particular topic is for a particular query. You can remove also all of them. You can compare two of them together. So this makes very good sense to compare the two topics together. Now you can also get the time series of the particular query over the entire corpus. For example, the 1000 tweets which we got over here are distributed in this particular manner. Now over here we haven't divided it among topics so that you can get an overall sense of how the topic is, how the particular query is behaving. Now further we'll move on to sentiments. Now we have performed sentiment analysis only on the two languages, so you'll see that over here. We have 1000 results, but the count over here would be a little less than 1000 because on the other languages the sentiment analysis has not been performed. The positive tweets are 724, the negative are 95, and neutral we have a very little amount, that is 4. We have also done sentiment analysis based on time series data. For example, how the sentiment, now you'll see over here the sentiments will be between contained between -1 and 1, -1 being negative and 1 being positive. Now we have averaged out on a daily basis the net sentiment so that you can understand how the sentiment is varying over time. Now I'll remove a few cities to understand the sentiment graph better. You can see over how the sentiment spikes are on a particular day for a particular query. Now it might imply that over here there was some positive event and over here there was some negative event based on the sentiment. But since the sentiment values are very low, that is 0.2 and -0.2, that is the polarity is very less, that means the impact of that event was not very much. If we get high polarity values, that means a significant event happened that day which caused the polarity to shift a lot. Now similar analysis has also been done based on languages, based on topics. As you can see, we have only English and France language over here, based on topics. Now even over here we can see that the graph is quite cluttered, so we can remove some of them and analyze each one of them individually as we want. Now we have also done analysis based on hashtags. For a particular query we are extracting which are the top 20 hashtags. Now these are not being predefined, this is happening for a particular query, as I'll show you later again. Now these are the top hashtags, these are the top mentions for a particular query, and this is the area this is the area chart. For example, how many tweets originated from each country. This is to make the visualization look more better, that's all. Now I'll make some another query and show you how the results are varying. For example, over here we have hashtags, for example social media, all these hashtags for the social keyword. Now I'll change the query to environment, and you can see how the distribution has changed over all of these. Over here the top hashtag is environment, which has been used for 70 tweets out of the 1000 tweets. Sustainability has been used, agri criminals has been used, pesticides has been used, and these are the hashtags which have been frequently used, and these are the top mentions. For example, Imran Hussein is used, then we have real Donald Trump, UN environment, and so on. So this is the entire front end which we have used, and that's all. Thank you.